Okay, lesson 6.2 is about properties of parallelograms. We have two objectives. The first is to use relationships among the sides and angles of parallelograms, and the second is to use relationships involving the diagonals of parallelograms and transversals. So, a couple of theorems here. 6.1 says that opposite sides of a parallelogram are congruent. So in the picture, AB is congruent to CD, BC is congruent to AD. Theorem 6.2 says the opposite angles of a parallelogram are congruent. So if we look at this picture off to the side, angle B is congruent to angle D, and angle A is congruent to angle C. Okay, then 6.3 says that the diagonals of a parallelogram bisect each other, which means they split exactly in half. So this segment is congruent to this segment because they're both half of the whole thing. Same with RT. Those two segments are split in half. Okay, then we've got theorem 6.4, which says if three or more parallel lines cut off congruent segments of one transversal, then they cut off congruent segments on every transversal. So what this is saying is, since these three lines are parallel, and this shows that this AC is congruent to CE, then we know that over here on this other transversal, each of the segments is congruent. So BD is what they give us, and that's congruent to DF. Okay, then consecutive angles. Consecutive angles of a polygon share a side. And, this is important, and are supplementary. So just so we understand what consecutive angles means, in JKLM, J and M, so J and M are consecutive angles. J and K are consecutive angles, but L and J don't share a side, so they are not consecutive angles. Okay. And supplementary means that they add up to 180. So if I knew the measures of J and M, they should add up to 180. Okay, let's take a look at some of these examples. Using algebra, find the value of x in quadrilateral ABCD, then find the measure of angle A. Okay, we know that opposite angles of a parallelogram are congruent. And if we look back at our theorems that we talked about just a second ago, that was theorem 6.2 that told us that. So we know that angle D and angle B should be congruent. So x plus 15 equals 135 minus x. So if I add x to the other side here, take this x, move it here, I have 2x plus 15 equals 135. Then I'm going to subtract the 15 from both sides, so I get 120. So 2x equals 120. Then I divide each side by 2, and I get x equals 60. Okay, so now I know x is 60. I can substitute 60 in for x to solve for the measure of angle A. So we know that the measure of angle B is x plus 15, and we know x is 60. So 60 plus 15 is 75. Okay, we've solved for angle B. Now we can use that to get angle A, which is what they've asked us for. Okay, so measure of angle A plus the measure of angle B equals 180 because consecutive angles of a parallelogram are supplementary. That's what we just wrote down at the bottom of that last page. And we know angle B is 75, so we're going to substitute 75 for the measure of angle B. Then if we subtract 75 from each side, we are left with 105. So the measure of angle A is 105. Okay, so we set these equal to each other because they're opposite, figured out what x was, got b, and then used that to solve for A. Alright, another using algebra problem. Find the value of x and y in quadrilateral KLMN. We know that the diagonals of a parallelogram bisect each other. So we know that x should be equal to 7y minus 16 because of theorem 6.3. So then we can substitute 7y minus 16, because that's what x is equal to. We can substitute that into 2x plus 5. So now we have 2 times 7y minus 15 plus 5. Sorry, 16 plus 5. Since we know x equals this, we use that in this equation so that we have only y instead of x and y in the same equation. So we're going to distribute the 2. So 2 times 7 is 14y. 2 times 16 is 32. Plus 5 equals 5y. Then we can simplify. We still have 14y. But negative 32 plus 5 gives us negative 27. Okay, so then if we subtract 14y from both sides, negative 27 equals negative 9y. So then we're going to divide each side by negative 9, and y equals 3. So since we know y equals 3, we can come back here to that first equation and figure out what x is. So we're going to substitute 3 for y, and I know 7 times 3 is 21, minus 16 leaves us with 5. So we know that x is 5 and y is 3. Okay, in this third example, we're just going to talk about the theorem. So, theorem 6.4 states that if 3 or more parallel lines cut off congruent segments of a transversal, then they cut off congruent segments on every transversal. Okay, and then there are some instructions to try to fold the blank card into 5 equal rows, and they tell you what to do right here. So if you want to go ahead and try that, you can, but you don't have to. Just make sure you understand what that means to cut off congruent segments on every transversal. So then there's a few check for understanding problems to try. Number 1, find the value of y. So again, remember, opposite angles are congruent, so E and G are congruent, set those equal to each other, find y, then find all these missing angles. Okay. 2, find the value of A and B. That's going to be just like the number 2 up here from our examples. So use substitution to help you in that one. And then number 3, you want to find EH based on what you know about all these other things. Okay, so if we know that these parallel lines cut off congruent segments, so like these are all 2, then we know that these segments are all 2.5, and we need to find EH. Okay, so go ahead, try those. When you get done, watch the check for understanding video so that you can check your answers and make sure you got the right thing, or figure out how to do the problem if you weren't sure. And I will see you in class.